will be brief, because I know it's late.
Final speaker of the day.
Yes. I just have to mention that this work was done in collaboration with previous speaker, or what was happening? Did I do something wrong?
Just do okay for a minute.
I cannot. That's not what I see on the screen. Yeah, let me try to do something.
Yeah,
okay. So this work was done in collaboration with the previous speaker, and I will go a little bit back in the problem. You will not really a little bit back, and a lot. So this problem started back in the 8th century when ancient Greeks. First, it's known that this was first raised by Homer in his poem, when he first spoke about something being in living that distinguished it from non-living. And he mentioned the concept of soul. That's what historically known to be the first time that the concept of soul was mentioned. And ancient Greeks was not looking at the soul from religious point of view. It was later in medieval times. They had a scientific approach to that. They really thought that soul is something that just distinguishes living from non-living. They said there must be something. And it's known that from dialogue with Socrates, and one of his arguments says, what is that when present in the body makes it living, a soul? So they had a word in about 5th century, a new word appeared in Greek, which means, and puchos, which means being alive, but its direct translation is and soul. So basically what they tried, different philosophical schools tried to understand what is that in living that makes it different from non-living, and what happened when living like a person at the beginning, but then, like for example, Pythagoras suggested that soul is present in all living matter, in plants and animals, and different philosophical schools discuss what is that. So just briefly, for example, to show that they were not that far from truth, they suggested Heraclitus, for example, view soul as being composed of fine kind of matter, and another school, Stoics, they said if soul acts or something in the body acts on the body, it should have the same, being composed of the same matter if it acts on the body. And they had a big argument also what happens after a living organism dies. It doesn't destroy, does it something destroys, or does it stay and dissolve? For example, the Epicurus believe that it's after living, when a person dies, there's something which is called soul, has atomic structure, and it's destroyed, just dissipates almost immediately. So they had many different views on what is this that makes living and what happens to it after death. And most of them believe it's material. There's some kind of matter. I just want to show you now that 2,000 years passed, but we didn't really make much progress in understanding what's distinguished living from non-living. So let me say how modern physics explains the living, the behavior of living, or processes in living organisms. First of all, from physics point of view, a molecule is a quantum system. So, and the quantum system, according to modern physics, must be governed by the probabilistic laws of quantum mechanics. So, in non-living systems, we know that chemical processes occur via random collisions, but that's not the case in the living system. For example, in the living, any metabolic processes that occur in the cell occur with the help of enzyme. I don't know if you know, enzyme is the protein molecule. Let me go back. And it's have this interesting shape. It consists of several links. And let me show you how the process, chemical reaction occur in the living organism, and you will see if we can discuss if it can be described with a probabilistic approach. So we have an enzyme, which is this protein molecule, and it can fold, it's just schematic of view, it can fold itself in a shape, so it's formed so-called active center of a very specific shape. And only molecule of this particular shape can sit in this center. Then enzyme, so they form some bonds with the molecule, and then enzyme break the molecule, reaction occur, and then it's ready for a new molecule. Again, for each enzyme can assist only one particular shape. So we don't see any chaos here. We don't see any probabilistic. It can be explained just by some random processes, and we see that it behaves as a well-tuned mechanism. And it's easy to just estimate that even to make an enzyme of several links, because it's made of several amino acids, it's a molecule that contains several links of amino acids. It's easy to estimate that, for example, if we want to make an enzyme of 10 links, we need 9 reactions. And even if we give each reaction high probability, 0.95, then to obtain just an enzyme of particular shape of 9 links, the probability is 0.62, which means that it's basically 62% chances that a certain metabolic process will occur. And we all sit here, we know that it appears that after generation, same processes appear again and again, repeat themselves again and again. So if you try to explain it with a probabilistic approach of quantum mechanics, you obviously see that it doesn't work. It's just not what we observe. So we can say that quantum physics in its modern state does not explain it. Another interesting fact I just want to share with you that was it was noticed by people who studied, scientists who studied evolution, that they know that DNA is very stable to mutation. The probability of mutation for DNA molecule do not exceed 10 to the -7. And you can think that in any change in environmental conditions, any radiation, anything should immediately cause the process goes in a different direction, but we don't observe it. It's observed it's other way around. It's observed that even if some chemical elements are missing and external condition changes, the process of reproduction doesn't change, and the DNA is very stable. So it feels that it's not at all a random process. Now I want to share with you 2 experiments that I found interesting. They show the difference in behavior of living systems versus non-living systems. The first one is the experiment done by Vysotsky and Kornilova, and they did experiment in isotopic transmutation in microbiological cultures. I choose the experiment, they're not the only one, but those are scientists they're doing experiments with very high accuracy, so we can trust their results. Very briefly, let me tell you what they did. Basically, what they did, they placed a microbiological culture, some bacteria and other cultures, yeast, in an iron deficit environment. And they wanted to check if, in this situation, the culture can, inside the culture, can make this transmutation. And for example, if we have manganese salt, you can see the isotope is 55. They said if they can place it, mix it with the heavy water, deuterium, and they expected that the living culture, this biological culture, can change it into ferrum 57. Why they chose ferrum 57? Because it's a very rare isotope, stable isotope of ferrum. It's missing from the slide, but it's a percentage in nature is about 2.2%. It's very rare. And basically what they observed was what we call cold fusion, which is considered now no direct explanation, but that's what they observed basically in plants. Because normally the energies for the fusion must be very high, but they observe it in the normal conditions. Let me tell you what they did. They placed this culture in 4 different containers. Basically, they had 3 control containers and 1 container in which the reaction occurred. They used the so-called method of cross concentration, where they needed heavy water and manganese salt, and then they created 1 container with the same nutrient medium but light water. Then they did manganese salt with light water and just deuterium. The reason it's a common procedure. The reason it is done this way, that in case if there is a ferrum present in any of the substances like deuterium or manganese salt, then it would appear in the control containers. So that's why they did it this way. And also they tested all the equipment they use with the Mesbauer spectrometer to make sure that there's no ferrum present. And also this eliminates any presence of ferrum in the container, in the walls of the container, because then it would appear in each of the control containers. But they observed clearly the presence of this rare isotope only in the last container, which means that the culture itself converted the salt in the, this transmutation basically occurred within the biological culture. So that's what they obtained. For other 2 containers, this container 2 and 3, there was no spectrum line for ferrum, but of this Mesbauer spectrometer that's specifically designed to measure this particular isotope, they observed it only in the last container, and they claim that they observed this transmutation in plants. They did many more experiments. I just focused on this one. The experiments are based on the experiments by another scientist, Herran. He worked about the 1960s. He did many experiments. He was the first who studied the transmutations in biological systems. He is known to find this reaction where potassium, you see if the potassium has number 39 very close to calcium, so it's known that he placed seeds, and not even seeds, he did experiments with chicken and other animals that if they supplied with low calcium nutrition, then the liver organism itself, or the seed, for example, convert potassium into calcium. That's what he observed. And I don't have the graph here, but also his results show that in the same culture, the change in potassium was exactly the decrease in the mass of potassium. It was exactly equal to the increase in mass of calcium. All other elements remained the same. So he was a little bit criticized later on because his explanation was not accepted, but his experiments I believe to be quite accurate. He was the one, by the way, who claimed that maybe we cannot apply physics rules to biological systems because he said all the physics laws were derived from inanimate world or inanimate objects. And he raised the question, can we really apply them to biological systems? And another experiment I wanted to share with you, which is also very interesting, and again from a trustful scientist. It was done by Romanian biochemist Vigier. He also experiments on plants. He wanted to study the difference between living tissue and dead tissue. What's interesting about his experiment is that he performed the experiment on the same plant. So the same tissue was alive and then the same tissue was dead. So very briefly what he did, he basically exposed a living plant to 200 atmosphere pressure, and what he observed is that this pressure, the living plant released some water, but it was, even under this high pressure, it still retained some water and remained alive. But the same plant, when it was dead, when it's at the same pressure, it's just released all water. And Makovsky obviously had his own explanation, his own theory. I want to mention it here, give him a credit. He said that there might be some gas structure in the living organism. He believed that the structure in vacuum that is no longer present in the plant when it's dead, and he believed that this structure holds water. He had a whole theory of hierarchy of those structures. Like he believed it's like a sponge that holds water. This experiment may have different explanation. For example, there was a big boom with this there was this new idea about, not new idea, let's say, the research about easy water, so-called easy water or exclusion zone, done by Pollack, where he found that near the surfaces, near membranes, the water forms so-called exclusion zone, the zone with special properties, and they're very, basically, it's a structures, in some way it's structured water. It could be provided as explanation, but if you think about it, then from a molecular point of view, the membrane of a living plant and the dead plant is the same. So the easy layer should be easy zone, easy water should form on both. But we observe only in the living plant that the living plant like hold the structured water. There was another interesting theory, I would say, because it's a theoretical result, not experimental. It was obtained by Preparata from quantum electrodynamics, like a solution, that so-called coherent domains can form in water. What's interesting that according to this solution, these domains occur not at low temperature, but at normal room temperature, 20 degrees Celsius. He calculated that almost 40% of volume of a normal water has these domains. These domains basically are macroscopic quantum objects because each domain, the bounds in each domain can be are in coherent state and can be described by the same wave function. And diameter of each domain is about 100 nanometers. He calculated also that each domain should have about 1 million molecules. So we can say, we can just have the hypothesis that maybe in the living plant, though the living plant basically form these domains, and these domains make hold the water in the living plant and make it basically structured water, in some way structured water. But if you think about it, the living plant do something to the water at quantum level, then how can it happen that the living, by means of what, by what mechanism the living can change the quantum properties of water? That's a good question. By the way, in all this experiment I mentioned, when we talk about enzyme and when we spoke about transmutation, it's all this process occurred at quantum level as if living organism can somehow affect it. So what does it mean that it's affected at quantum level? Does it mean that somehow living biological system can change the wave function, can affect the wave function? And if you think about macroscopic, the previous presenter mentioned the superfluid vacuum. It's a very interesting, the reason she mentioned it because it's a fluid that has very interesting properties. It's basically a macroscopic, maybe the only known macroscopic quantum system because it's described by the same wave function. And what she mentioned before about it has, for example, the following interesting property. If there is a vortex, they say you have two vortexes in superfluid. If you separate them with the wall and you change the phase slightly of one vortex and you open the wall, the other vortex eventually will adjust to the same phase. So that's what she discussed. It's like, it looks like something similar we can imagine can happen in physical vacuum. If physical vacuum has similar properties, then the same correlation, it can describe the correlation. So, yeah. So in our opinion, and what follows from, again, that's what the previous presenter explained, that if you introduce physical field and if you include it as a term in the equation of motion, then Schrödinger equation becomes the condition for stable orbits, for example, for the electron motion in the atom. And it also follows that this vacuum should provide the stabilizing force. It's come also strictly mathematically that it's provide force that stabilizes the electron in its orbit, similar to the basically the force, like not the Hooke law, but something similar that stabilize the motion. And also it follows from this idea that if electron is moving in the atom, it should form some kind of structure in physical vacuum. It can be like coated with physical vacuum. And if you think about that all quantum objects, that's what we believe, that all quantum object has basically continuation in this physical medium. And then we should consider the interaction and we should consider what's happening in the physical vacuum. And it's something similar to if we study, for example, wooden chips moving in water. If there's a vortex and you just study the motion of wooden chips without considering the water, you can describe the motion, but you wouldn't understand what causes the motion. We should include water in consideration. The same way, we believe that we should include physical vacuum in consideration when we talk about biological processes and other processes. And as the previous presenter said, that it's like this additional hidden variables, this parameter that can bring from probabilistic interpretation to deterministic interpretation, can explain what causes these processes and how these processes occur. That's basically all I want to say tonight. I know it's pretty late. Is there any questions? Thank you.
Yeah, but sorry, I might have misunderstood. Are you saying that plants and seeds perform cold fusion?
No, I said they observe, basically they observe transmutation at low temperatures. What they observed was a transmutation of chemical elements at low temperature. That's right. So what was the question about the, I can tell you the details of the experiment. Basically what Caravan did, or you want to know the previous one?
Well, no, just this here. Am I right in saying?
This I just briefly, I didn't want to go into details, but basically what he did, he placed seeds and he observed the growth, he studied the growing of 840 seeds, and he placed them in the environment that has potassium, and he measured later on that the seeds as they grow produce calcium. So basically we are dealing with transmutation within plants.
Two light elements together and made a heavier one.
That's what we observed, yes. So with the help of the proton, potassium, in his experiment when he measured it, he found that they produce calcium.
How did he do this measurement of Kathy? You'd have to destroy the plant or the seed in order to calculate how much calcium they have. They do spectroscopic analysis of the thing that's before and after?
Yes, they did it before and after. No, I think in this particular experiment, they did a spectroscopic analysis, but in this particular experiment, he measured, I think he just measured the mass. What he did, he found that the mass of potassium decreased, and then the mass of calcium he measured increased by the same amount.
But Would you destroy the seed in order to find the mass in the first place? I mean, how?
Yes, I think you're right. I think they should destroy it. I think they have to basically put it in powder and everything.
Look, we have a question, where does this proton come from? Is it from the acidic solution?
Yes, I did this experiment.
Hydrogen
I'm not a specialist here, so I cannot.
So basically the
But
plant
yes, it was in the original solution, yes. Okay.
basically the plant is another form of the plant taking energy.
Yeah, that's what he also was interested if he can produce a reaction that removes, for example, radioactive materials. He had some experiments that with certain culture, he showed the decay occurred faster, that he believed that it was the case. But again, his experiments, I trust those other, the source in Karnilova, I know I can trust their experiments. His experiments are not very well described in details. That's one thing he was criticized because he did not put all the details. He did many experiments, but that's so again. That's the details I don't think. But the experiments was very. The experiments was described in all the details. This one we can trust.
Have they repeated it?
Yes, they had many. They did it with many methods. They actually they performed the same experiment using different techniques to measure if that's only technique that showing. They did the same experiment using different techniques. They get the same result. Yeah, they're very accurate in their experiment.
Okay, Wolf and then Daniel.
Okay, earlier before some earlier slides, you said there was a probability of mutation of 10 to the minus 7th. I'm just wondering, is there a time scale that's associated with that probability? I mean, it can't just be, what, forever? Or? There.
Yeah, the previous slide.
Probability of mutation in these molecules can exceed 10 to the minus 7th.
It's not for one molecule. It's not for one molecule. They just study across the cell DNAs. It's not just for one molecule at one time.
I'm wondering what time period? And if there's no time period, then I mean, what does probability mean without some time?
But DNA, it has its own. I mean, it's a process. You cannot just give it the DNA and watch what. You cannot separate and watch what happens. They just observe it across all biological, certain systems and see what happens. I don't think they could just make one do it over a long time. So I see what you're saying. You mean that it's if you do it for a long time, it would may show more mutations. That's what you mean?
But the mutation happens when the DNA replicates itself.
Yeah, but it
so
doesn't.
This is the probability of a mutation at replication. That's how I would understand
Yeah,
it.
it's not like you cannot take one DNA and just study it. It's a process.
Yeah, I know, but I mean, if I have two balls, they're painted black on the top and white at the bottom, and they're all black when they start off, and then because of thermal action, some of them reverse. Then I would say if you take a tenth of a second and look at it, most of them will still be black. Right? If you take a year, there'll be some other.
Yeah, but how often does DNA replicate?
So the calculation of probabilities has to be time dependent.
But
right?
how often does the DNA molecule replicate? It's with any cell division.
Yeah, it happens all the time.
Okay. What's this?
Question from Daniel.
Yeah, two questions. First, do you mean that the transplantation is possible only in living system?
It's not my claim. I just this is what they claim. Yes, that's what they found. Yes.
Yeah.
Yeah, but I trust these researchers. I know them personally.
And
Trust
when you say when you observed this mutation, it means that you make it in a system which are living.
Yes, that should be in the living. Yes. Yes, not that. Yeah, that's what.
And
No,
in
the process is not
it's
explained.
plants or
No, don't ask me how it happens. The process, nobody understands how it happens.
yes, it is in plants.
Yes, it's bacteria and yeast.
In
Yeah,
bacteria?
and yeast. Yeah, bacteria and yeast.
Yeah.
So that's what they work on.
And when you say that from the life to the death, you have the water which is peer of the living system, and this means that something retained.
That's exactly the point. The question is what retain. Basically the question is how can we describe with physics laws how the living plant do something to change the structure of water, because we don't have any explanations how it can affect, for example, the properties of water at quantum level, how the living can do it. Because according to modern biology, the plant that is living plant and the dead plants have the same molecular structure. It's not from the molecular point of view they're identical, but they behave differently. So the question is how it's possible.
Yes, I just discussed with somebody 3 days ago, and we had the same conclusion. Structurally, there are no difference between death and living, but there's something between, there's something which must exist. But what is it?
Yeah, that's what my topic of here is.
Yes, and what you said here, you say that the living system, like plant, modifies the property of the water.
Yes, basically, the reason I spoke about it, I just wanted to show that there is no explanation. There are some experiments which are, like you mentioned, with water and with transmutation, which can be trusted, but there is no, for example, modern quantum mechanics does not describe this process. There should be something else. And in view of what SOTINA said, that, for example, if we include some additional, with the vacuum or some additional information is needed. Where the, even with enzyme, what tells enzyme how to fold and molecule to fit in this. They're not definitely described by probabilistic ideas. There should be something else. You're absolutely right. There should be something else.
Myself, I work a lot on the water properties in the microscopic structure. And I made my thesis for engineer and diffraction of slow neutrons in liquids to analyze what the plants. In fact, it's a water. It is a mix of gas and solid. It's between the two. It always changes. And sometimes we speak about the memory of water.
Yeah, that's right. That's
with Benevist and so on. And I have a friend who presents paper here, but not just for the proceedings. It's Cyril Smith, who works on the properties of waters, and he's very serious, and he shows all the
that's why they like this theory of coherent domains, because
synchronization process in the water, but with the problem also of medication, dissolution of medication. Homeopathy, yes. But when I have studied the process, because I'm very intuitive in physics and biology, what I made, and I'm sure that in contact with a sort of molecules, the water can take an imprint of complementary imprint of the molecule, and when the molecule disappears, it can continue to keep.
That's what Benveniste found. That's what Benveniste's experiment.
Yeah, but I'm sure that it can happen. So now the problem is how the living plants make to modify.
That's a key point. Yes,
yes.
That's the most interesting.
This interests me a lot.
And what's interesting that modern physics doesn't have the answer to that.
You cannot explain it without
medium.
You cannot explain without medium.
Without vacuum, yeah.
Physical vacuum. You cannot explain. Only in physical vacuum there is this
processes.
We can explain.
Yes.
Yeah, so should be, if we can include medium, then we can include processes and medium.
question, Sydney.
Yeah, I was going to ask, since living systems seem to, from what I understand a little bit about it, living systems are at the intersection between, or at the edge of non-equilibrium thermodynamics. So how much do you think that plays into this phenomenon?
Which experiment you're talking about? Just all?
And living systems.
The just in all living system. You know, all the processes, thermodynamic processes, all this, you know, statistical random collisions and all these things, they're quite well known, but you cannot explain with these theories like this. For example, the fact that some process appear from generation to generation, it doesn't, all this known, but it doesn't explain. When you start to explain it, you will see that it doesn't work just.
Schrödinger was the first who knows this.
Yeah, Schrödinger, in his book about life, he was the first who said that probabilistic interpretation doesn't explain life.
So we got a few questions. I think, Wolf, you had a question.
I just can't.
Your comment, and you've got a question. Right, so we're probably on time for those three.
Okay, question on this experiment, the magnesium with iron. Living, I mean, it's a tremendously interesting result. So, but now the question of when is something dead, and there's always an immediate decay process that's going on. So
they didn't do it. Oh, you go ahead.
yeah. So my question is, I would expect that there would be some time delay measurement in this.
No,
so
they
that
believe
immediately, if it, you know, how do you kill a plant?
They believe they believe that this culture. They believe that they just look at it purely like you look on non-living system. They didn't really study dead or living. They just had this culture. They measure that there is no ferrum present. They predicted before. They was expecting certain reaction. They make it favorable for certain reaction. And then they just study basically. They study ferrum. They didn't distinguish ferrum in living and ferrum in non-living. Yes, they can kill this culture. They powdered it, but element is still there. The element ferrum, the isotope of ferrum, they said it's the same isotope. From their point of view, Vysotsky and Kornilov, they don't believe that living isotope of ferrum is different than non-living, and they just they take this dead culture from the first from each of the containers. The first three control containers show no ferrum, but the last container show that now they have ferrum. With Ms. Bauer's spectrometer, they describe the experiment very clearly, so it's easy to answer your question. So they measured that there is a ferrum present, and concentration of this ferrum was quite noticeable. It's not, and again, it's something that's isotope. What's interesting that normal ferrum is abundant in nature, but for isotope that they studied 57 is very rare, but for biological system, they don't distinguish from one to another.
Right, well, I mean,
but
it's
so
extremely interesting that something like this even happens at room temperature. No, that's
right.
But to associate with life or death is another question.
Yes, this was not about life and death. Here I just wanted to point out that we do have the biological system can affect, basically, if you accept this correct experiment, then this means that living organism, while being alive, can affect the quantum properties of the atom somehow, and we don't know how, because that's why I pointed out. It's not about living and death. The other experiment about the seeds, there's no good description of this experiment to answer all the questions, but they was kind of repeated some of his experiments. They describe it very in details. The other one, interesting, but there are no enough.
Okay, Alf?
Yeah, I just want to say the arguments about probability of biological, chemical, and quantum processes should not forget that a 1% solution is like 10 to the 23rd or 4th or 5th atoms per liter. So what you think of as being improbable ceases to be so improbable when you've got 10 to the 24th atoms moving around with a mean free distance of millimeters at room temperature, and there's a lot of action going on in there. So some of these arguments that seem to say a chemical reaction should be improbable, if you put it in those numbers, you say, well, on a scale of doing an experiment over a couple of minutes, there's
No.
It becomes probable.
It is known right now in physics that we cannot produce transmutation in cold. Like according to modern physics, we need lots of energy and high temperatures to produce transmutation in normal conditions. Yeah, cold fusion. Yeah, cold fusion. But I mean, But I mean, I'm talking about what's accepted. Yes, we all heard about cold fusion, but it's not. It's not produced yet.
Have these things been duplicated? I mean, has been verification of the same experiments?
I know they did the same experiment with different measurements. That's what I know. But at the same group. I don't know. Do you know if anybody repeated their experiment?
Yes.
You know this? No, they repeated, but their school, they have
another school.
Another group. No, I don't know.
Maybe. I don't know.
Yeah, I don't know.
I don't know exactly.
Follow-up question here.
Ivan, my name. In the last interview, mentioned that something phenomena produces in the physical vacuum. Okay. But vacuum, this means is there nothing. What? For me, where is vacuum is nothing. How can produce some phenomena in nothing?
That's exactly.
No,
that's what
no, I want to continue.
Actually, sorry.
There must be other than nothing. There must be ether.
Yeah,
You don't
Space
think
is
so?
empty.
Yeah, that's what. Yeah, I agree. That's exactly what.
Ether must be produced any experiment, any phenomenon.
That's thank you for this question, because that's exactly the main point. That if you assume that vacuum is nothing, you couldn't explain this. You cannot explain this. Then you will have again we come back to the probabilistic interpretation, which does not explain this process. That's exactly right. There should be some medium. That's we believe that too. There should be some medium which we have to study in order to understand this process. Without studying the properties of this medium, we cannot explain what happens, where this information comes.
And that medium is somehow in living things that's able to do
It's
that.
everywhere. It's living things. Yeah, exactly. Should be killed
But dead things couldn't do the same thing.
That's an interesting question. Then that means that that living biological system, they can somehow affect through vacuum. Basically, what our idea is that each quantum system has continuation physical effect. So we cannot say just electron. It has more. We are more than what we see. We have continuation physical vacuum, and there's some interactions there, other than material.
That would explain why they can't do it at room temperature if non-animate matter can't be transmuted in our cold fusion at room temperature. Somehow living things can do it, and there's some difference there.
Right, the living things some have different structures, probably in vacuum than something like that. It's need to be studied, I can't give the answer.
10 to the 10 atoms per cubic liter? A good vacuum in the laboratory? What? Got an experimentalist here? What's the best vacuum you can pull?
Outer space.
Huh?
Outer space.
Deep
Yeah.
space?
That's what intergalactic space is like one hydrogen per cubic meter. One hydrogen per cubic meter. I mean, that's a laboratory vacuum. I mean, if we're doing experiments here on Earth to determine, that's like 10 to the 10th or something atoms per meter.
But that's a different question. To have empty space and then there's a particle in it, that's a different question than whether empty space actually has properties. And I personally believe, and my presentation said that it does, and you are the empty space.
Of course. But I mean,
when you're in equilibrium rather than in excited living state.
we're talking about the probability of improbable things, right?
Yeah, it will not say because
And
I
that the
didn't
argument,
say
the basic
that
argument of the church is the probability of improbable things. Things that shouldn't be because they shouldn't happen by chance. And I just don't see anything you can do in the laboratory because when you have 10 to the 10th atoms per cubic meter, you're fooling around.
Well, if you
These things aren't improbable.
start by assuming there's particles,
This is another version of evolution. This is just a space version of
thought we were going to get away with
I'm sorry, your question about time, I didn't
Good to see you.
basically that's not time.